Hello and welcome to the CYBERHERO. Here we are going to know in next series that's called cryptography. So this video is for introduction to cryptography. So let's begin start. If you are new here, please hit that subscribe button. So let's go. What we are going to see here, what's cryptography, objectives and some terminologies and its types. Then we will go for its some basic types. Symmetric, asymmetric, then we will go for hashing, some digital signatures. So we will see then real world examples, and last we will summarize this video. So let's begin. What is cryptography? Cryptography is the science of securing information and communication through mathematical techniques that make data unreadable to unauthorized user. In simple words, it's a way to hide protect information using codes so that only the intended person can understand it. So main purpose of cryptography is to protect data privacy, to secure communication, to ensure that data is not modified or forget. For an example, when you send a WhatsApp message, it's automatically encrypted so only you and the receiver can read it. Either WhatsApp cannot read it. So let's begin. Go to next slide. Here we will discuss some objectives of cryptography. The first main objective is confidentiality. What is confidentiality? Protects data from unauthorized access. Example, only authorized user can read encrypted emails. Then we will see integrity, ensures that data is not altered during transmission. For an example, if even one bit of encrypted data exchanges, the system detects it. Another one is called authentication, that verifies the identity of user or systems. That's called authentication. Example, logging into the online account is confirming that you are the correct user. The other objective is non-repudiation, prevent the user from denying their actions. Example, digital signatures ensures that sender cannot deny sending an email. We are getting it. This model is also called CIAN Pulse model. CIA Pulse N model. Then we will see basic terminologies. Plain text, the original readable message or data in simple words. Then ciphertext, the scrambled, unreadable version of plain text after encryption. Then encryption. What is encryption? It is a process of converting plain text into ciphertext using an algorithm and key. Then decryption, converting ciphertext back into readable plain text using a key. What is the key? A secret value that controls the encryption decryption process. After that, algorithm is a mathematical formula or rule used to perform encryption and decryption. Types of cryptography: symmetric cryptography, asymmetric cryptography, and then hashing function. Symmetric cryptography use the same key for both encryption and decryption. It's very fast and suitable for bulk data. The main challenge is securely sharing the secret data. Here's some, for example, AES, DES, 3DES, both of these. Then for asymmetric key cryptography, uses two keys, a public key for encryption and private key for decryption. It's more secure, but it is slower than, obviously it will be slower because it takes two keys. For an example here, RSA, ECC. Then some hash functions, no keys are used. Data is converted into fixed length string hash. It's one way you cannot get the original data back from the hash. Example, MD5, SHA1, SHA256. Then symmetric encryption simplified example. Hope this example make you clear the symmetric encryption. Sender and receivers agrees on shared secret key. Sender encrypts the message using that key. Receiver decrypts that message using that same key. Example, if the key is X, plain text is equal hello, Ciphertext is equal to IFMMP. Receiver uses the same key X to get back hello. What are the advantages? Fast and efficient, great for encrypting large file. Disadvantage is key description problem. How to send the key securely? This is the main disadvantage with this one. For asymmetric encryption simplified example, here we say every user has two keys, public key and private key shared with everyone. Public key, private key kept secret. Sender encrypts data using the receiver's public key. Only the receiver's private key can decrypt it. Example, use it in HTTPS, email encryption and digital signatures. Hope so it's clear. Now we'll move towards the hashing. Hashing converts data of any size into fixed size string, that is called hash value or digest hash function, we can say hash value. So what are the properties of this hashing? One way, irreversible. Once it is converted, it can't be irreversible. Unique for each input, ideally. For example, MD5 hash, whenever you type hello, it will generate the same hash for that hello. Use it for verification and integrity checking. Example here, hash hello 2FS1 SHA256 output. If one letter, example, changes HELLO, this is one is small here, this was in caps, the hash becomes completely different. So it becomes difficult. Common algorithm SHA1, SHA2, SHA3, black 2, so on. Now we will move to digital signatures. Digital signatures are the electronic fingerprints that verify the authenticity and integrity of the data. What are these? Fingerprints, electronic fingerprints. Sender signs data with their private key. Receiver verifies it using the public key. While it's used, email security is software authenticity, blockchain and contracts. So now say what are the applications of this cryptography. First one, secure communication via HTTPS, VPNs, encrypted chat apps like WhatsApp, Telegram, so on. Data protection, disk encryption, file encryption. Then authentication, the password tokens, digital certificates. Blockchain, transition, verification and hash. Here is you. For email security, PGP, SNIM is something. Then we will see a real world example of an HTTPS. HTTPS uses SSL, TSL, which is based on asymmetric encryption. Your browser verifies that website's digital signature. Data is then exchanged securely using symmetric keys. Example, when you visit www.gmail.com, all your login details and messages are encrypted. So what are the limitations and challenges? Key management. Losing private keys, data loss. In simple words, algorithm weakness, outdated ones like MD5, DES can be hacked. Performance overhead. Encryption can slow down systems. Then human errors, weak passwords or poor key handling reduced effectiveness. Let's summarize this video. Cryptography is equal to science of secure communication. Simple words. It ensures confidentiality, integrity, authentication, and non-repudiation. Modern digital security systems like HTTPS, VPNs, and blockchain totally depend heavily on it. A solid understanding of cryptography is essential for cybersecurity professionals. This was the end of the chapter 1, that is Introduction to Cryptography. If you learned something new today, please hit that subscribe button and make sure you like that button. Thank you. See you in the next video.